Okay, hello class and welcome to chapter 9, and we're going to talk about conic sections in this chapter. So let me show you what those are. Okay. So I have that somewhere over here. Let me look at that. And we're going to talk about conic sections. Here they are. Oh wait, did I say conic sections? Comic sections? Oh, I meant conic sections. I'm sorry. Okay, so conic sections, those are something different. Those are these things right here. Okay, and the reason a conic section is called a conic section is because if you were to slice a cone in various ways, you end up with these different shapes. If you slice a cone like over here, where the cone is where the slice is taken parallel to one of the sides, and these are double sided cones, or they go both directions. But if I were to take a slice parallel to one of the sides of the cone, then I end up with a parabola. Okay, and as you can see, you only get one parabola. If I take a slice of my cone parallel to one of the bases, then I get a circle. If I take a slice of the cone this way, kind of not quite parallel to the bases, but, then I get an ellipse. And if I take a slice that goes through both sides of the cone, I can get a hyperbola like this, or a hyperbola like this. We'll mostly be talking about this type of hyperbola. So the four types of conic sections we're going to be talking about is a parabola, circle, ellipse, and hyperbola. Okay? And today we're going to be talking mostly about parabolas. Okay? That's section 9-2. So this is a little bit different than definitions of parabolas you have had before. So the definition of a parabola in this case is the set of all points that are equidistant from a line called the directrix, and a point called the focus that is not on the line. So if you look at these two pictures here, this point, let me get my pen here, okay? This point right here is called the focus, and this is the directrix. So this distance from here to here, okay, and the distance from here to here is the same. And if you're right at the vertex of the parabola, it's easy to find the focus and the directrix, because that number comes out down here, and that distance is called P, or in this case, in this picture I have here, they call this A instead of P. In your book, they call that P, and I'll talk more about that. Now, you can generate a parabola by finding the parabola is generated by finding all the points that are equidistant from this line called the directrix and from this point called the focus. So if I go perpendicular to this line called the directrix, this distance right here is the same as this distance right here, and if I find all the points that are equidistant from that line, from here to this curve, and then from that point to that point, from here to here, that's called the focus. So from here to here and here to here are the same. From here to here and here to here are the same. And then and that's how we generate the equation or the curve of a parabola. Okay? If you take this parabola and you were to spin it around this x-axis like this, something like that, what you get is this shape that might look kind of familiar, maybe like a satellite dish or something like that, and that's called a paraboloid. Okay, and that's a three-dimensional parabola, which is just generated by spinning that thing around the x-axis. And probably when you get to calculus, you will you will find the volume of a shape that looks like that. And the other thing that's kind of cool about parabolas, like in a satellite dish, and why they're so nice, is because if I have something coming in this way, it bounces off the parabola and it hits that point, which is called the focus. So if I bring in a ray straight into that parabola, it's going to bounce off and it's going to hit that point called the focus. And that's why you see those, like if you have satellite TV or you're looking for alien life or whatever, because it concentrates all of the rays coming in here at the focus of the parabola. Okay? So now we're going to talk about equations of parabolas. If you see a parabola, now in this case we call this standard form. We're kind of used to the form y equals ax squared plus bx plus c for a parabola, or y equals ax minus h squared plus k for a parabola, which this is vertex form. And whoops, I forgot an x there. bx plus c, and that's called standard form. But when we're given this definition of a parabola, which includes the focus and directrix, then we would write these ones, the kind we're used to, a right side up parabola with y equals. These can be converted into this one over here. If you have a sideways parabola, meaning one that opens to the right or to the left, then you have an equation where you have a y squared instead of an x squared in it. And we'll talk about that. Okay? And then there are these equations which tell you, or these tell you where the vertex is, the focus is, the directrix is, and so on and so forth. Now I think the best way to find let's see the sample problems. The best way to find the focus and the directrix is not so much plugging into the equations and these formulas, but rather to draw a picture of it. So let's do a couple problems. All right. So hold on a second. I'm looking for my recorder right now. Here we are. There we are. Okay, I just wanted to make sure that I was recording. So getting back to the notes, I'm going to put this up here. So let's do this problem. Find the vertex, focus, and directrix of each parabola. Okay. So first of all, if I were going to graph this parabola, which we're going to try to do right now, is we'll call this the x-axis, that's the y-axis, and this one is going to open either to the left or to the right. Now if you go down a little quick tip, if you go down to here, if p is greater than 0, meaning the number in front of the x is positive, that means that this parabola opens to the right, like this. So this one would look like this if it's a y squared parabola, and if it's less than 0, meaning this number up here is negative, it's going to open to the left, like that. If p is greater than 0, then it opens up like this if it's an x squared parabola like this one, and if p is less than 0, which you kind of already know, that is a downward parabola. So that's what this stuff down here means. So first of all, I know that this is a left opening parabola, and they want us to find the vertex. Well, the vertex is easy because there's no h or k in this one, so the vertex is just at 0, 0, which is right there. And the focus, since this number over here represents 4p, right? So you know that 12, negative 12 equals 4p, so p equals negative 3. So what that means is that the distance to the focus and the distance to the directrix are both 3 units, because that point is the vertex of the parabola. It's equidistant from both the directrix and the focus. So if I come over here and draw in a line, and since this is negative, since p is negative, it's opening to the left. My directrix is out here at x equals 3. Okay, and then my focus is over here at x equals negative 3. Okay? And then I could kind of sketch in my parabola, which kind of looks like this. Now another nice thing to do would pick some other points on that parabola. So say I do plug in the point x equals negative 3 in here. So if I were to plug in, make a little table of values, x, y, and if I plug in negative 3 for x and solve for y, I get y squared equals 36. So y equals, right, I plug in negative 3 in there, I get y equals plus or minus 6. So in other words, there are 2 points over here, one at 3, 6, and one at 3, negative 6. Oops, negative 3. Negative 3, 6, and negative 3, negative 6. So that's how you would sketch that. We found the directrix, x equals negative 3. We found the focus over here. Excuse me, the directrix at x equals 3, and the focus over here at x equals 3. Okay? Alright. You got that? Good. Okay, so now we're going to move over here to a right side up parabola, and I know it's right side up because P appears to be positive. Alright, so if I were to work with this one, first I want to get it x squared equals. So I'm going to divide both sides by 2, divide by 2, and I get x squared equals 4y, which means that p equals 4p equals 4, right? Coming from this equation, that's the number in front of the y. So p equals 1, which means that the vertex, so this parabola right here, it's it's a right side up parabola. I know that because this number is positive. The focus is 1 unit away from the vertex, and the directrix as well is 1 unit away from the vertex. Okay, so this would be the line. This is y equals negative 1, and this is the focus, which is 0, 1, and this is the vertex, which this is the x-axis here, y-axis, and the vertex is over here at 0, 0. And if I want to sketch this again, probably what I want is a couple other points. Now in this case, it might be wise to plug in a number for y and solve for x. Okay, so I know that if I plug in a number for y, if I plug in negative 1, I'm not going to get any answer, right? Because there is not, the parabola has to be above the directrix in this case. So let's plug in something above, let's say I plug in 1 for y over here. So if I get x, that gives me x squared. X squared equals 4y, which gives me that x squared, x squared equals 4, sorry. So x squared equals 4, so x equals plus or minus 2. So in this case, when y is 1, I get x is plus or minus 2. And so up here I have x is positive 2, x equals negative 2. I'd say that this is 1, this is 2, 1, 2. And so I get this graph that's kind of a fat parabola that kind of goes. It's kind of hard to draw this, but I get a parabola that kind of looks like this. Generally speaking, if this number is a small number, then your parabola is going to be wide, okay? And if this parabola is if this is a big number, then your parabola is going to be wide. And if this is a smaller number, like a number less than 1, then it's going to be a skinny parabola, okay? Because if this number is less than 1, then I would be dividing by a number less than 1, which would make the number in front of x squared big, which would mean that like a y equals 5x squared parabola, that would be a skinny parabola, like that. So the smaller this number here, this 4p in front of your variable, the smaller this number is, the skinnier your parabola is, and the bigger this number is, the fatter your parabola is going to be. Alright? So now we have, now these are for parabolas which are centered at the origin, which are easy. So now we're going to look at some parabolas and some questions which, in which the center of the vertex, the vertex of the parabola is not at the origin. Okay? So I'm back. I know you get bored during these lectures, so I have to intersperse some leader humor. I made up a joke. What did 2 to the 3rd power and Fidel Castro have in common? Extra credit if you answer this one in class. They're both Cuban. Okay. Now moving on, we want to do this problem right here. Okay. Find the equation of a parabola. Find the equation of a parabola with a vertex at -2, 3 and a focus at 0, 3. And like I said, it's kind of better to draw a picture of it than it is to try to memorize a whole bunch of equations. I always think that's the better way to do it. So I'm going to try to draw an XY axis right here. And so find the equation with the vertex at -2, 3 and focus at 0, 3. So I'm going to draw in the point -2, -2, 3, which is about here. Okay? And focus at, sorry, my dog's barking in the background. And a focus at 0, 3, which is, where's 0, 3? Right here. Okay? So if the focus is here and the vertex is here, that must mean that my parabola is going this way, right? Because the focus is always inside of the focus is always inside the curve of the parabola, and the directrix is out here, right? In this case, this would be your directrix at x equals, since this is, since these are 3 units apart, since this is at 0, 3, and this is at, and this is at -2, 3, sorry, these are 2 units apart, and so this would have to be x equals, you have to go 2 units from -2 this way, since this is 2 units from -2, so this would be x equals -4 if you're looking for the equation of the directrix. Okay, and so now you know that using the formula, this is a y parabola, so it's going to be x, so going back, this is going to be a y squared parabola, since it's opening to the right or left, so it's going to be y minus an equation of the form y minus k squared equals 4p x minus h, okay? And in this case, that's a k over there. It's kind of hard to write at my desk. So in this case, k is the y coordinate of the vertex, so in this case that would be up 3 units from there, so it's going to be y minus 3 squared equals 4, and since the distance, p is the distance from the vertex to the focus, or from the vertex to the directrix, so p in this case is 2. And I make that positive because it's opening to the right. And then h in this case is the x coordinate of the vertex, so it's going to be plus 2, okay, because it's minus -2. And so simplifying that, you get y minus 3 squared equals 8 times x plus 2. And we're done. Now, if you want to plug that into your calculator, which we'll be doing later on when you do your conics project, you have to break this into 2 parts, where you take the square root of both sides, and then one will be plus and one will be minus, because this is not a function. It's a function of, it's y as a function, it's x as a function of y, but it's not y as a function of x, so it would not pass the vertical line test if you try to graph it. So if you want to put it into your graphing calculator, you have to break it into 2 parts, a positive part and a negative part, which we'll talk about later on. Okay? Going back. Next sample problem. Find the focus vertex and directrix of the graph of this one. Okay? So again, what I would do is sketch a picture of it rather than memorize a bunch of formulas. Okay? And since this is y minus 3 squared, again, this is going to be a sideways parabola. So I'm going to try to do an xy axis. And the vertex of this, since this is plus 1, the vertex is going to be at -1, comma, positive 3. So if I go back 1 and up 1, 2, 3, then I have the vertex of this parabola. And since I know that this number is positive, again, I know it's a right opening parabola. And then you probably want to find a couple points. One good point to find would be the y-intercept, okay, so, or intercepts in this case. So if I plug in x equals 0 in there, I get y minus 3 squared equals 20 times 1, right? Which gives me y minus 3 squared equals 21. This gives me y minus 3 equals plus or minus the square root of 21, which gives me y equals, when I add 3 to both sides, 3 plus or minus the square root of 21, which is kind of a bad number, but it gives you an idea. Square root of 25 is 5, so square root of 21 is something less than 5, like 4 point something. So 3 plus 4 point something would be one of your y-intercepts. So that would be like 7 up here or something. And 3 minus 4 point something would put you at negative 1 point something. So as you can see, since this number is a big number, this is going to be a fat parabola, okay? Kind of going like that. That's not very symmetric, but you get the idea. Now to find the focus, since P, 4P equals 20, right, that means that P equals 5. So the focus is going to be 5 units away from this vertex, which is at negative 1, 3. So rather than use the formula, you could use a formula, but if you just go negative 1 plus 5 in this direction, this is going to give you the focus. So that focus is going to be at 4, 3, because the distance from here to here is 5. And then the directrix, okay, is going to be over here 5 units away from negative 1, so that's going to put you way over here. Whoops, that should be a dotted line. We'll put the directrix over here at x equals negative 6, because that's 5 units away from negative 1. Got it? Good. Don't fall asleep while I'm talking. Okay, next one. So in this case, what you have to do is complete the square. So, and that can be a little bit tricky, but it's a good exercise for you. So it's the same idea, but first we have to get this into a form of a parabola that I can work with. And so as you can see I have x squared minus 6x. So I'm going to complete the square on the x squared part. And to do that, I take half, oops, wrong tool. I take half of negative 6, so I would get x minus 3 squared, okay, minus 4y plus 5 equals 0. But when I completed the square, I added negative 3 squared to this side of the equation, and so I need to add negative 3 squared to this side of the equation, which is 9. Because if I FOIL this out, I get x squared minus 6x plus 9, so I need to add 9 to this side. Now what I want to do is bring everything except this x minus 3 squared over to the right side of the equation, so I get x minus 3 quantity squared equals 4y, and I'm going to subtract 5 from both sides, plus 4, and what's nice about that is now conveniently I can factor out a 4 from this, 4y plus 1, okay, and now this is in the standard form, the directrix focus form of the parabola that we've been working with. So if I were to graph this one, okay, you don't have to graph it because all it asks you for is the focus, the vertex, and the directrix. But this one is since this is x squared parabola, it's a right side up parabola, okay, up down parabola since it's x squared, and it's right side up since this number is positive. And the vertex is at 3, negative 1. 1, 2, 3, down 1. Okay, and the focus, since 4p equals 1, that means that p equals 1/4, right? And so that means that the focus is only 1/4 of a unit from that vertex. So if I go up 1/4 from this point, which is 3 comma negative 1, then this focus right here would, why did I write negative 2? I don't know. 3 comma negative 1, okay? Then this focus is going to be at 3 comma negative 1 plus 1/4, which puts you at 3 comma negative 1 plus 1/4 puts you at negative 3/4, right? And the directrix is going to be 1/4 of a unit away from there. So I'm going to try to draw in a directrix. Let's make it a different color. And going straight across this way, okay? The directrix in this case would have the equation y equals negative 1 and 1/4, right? Because it's 1/4 of a unit from here to here and 1/4 of a unit from there to there. Okay? Good. Are you ready for another joke? You're going to have to wait till class. Sorry. Okay. Next one. A satellite dish. Okay? So this is kind of like that, the picture that I have on the front side of this handout. A satellite dish shaped like a paraboloid, and I remember having a question very similar to this on a test, so it'd be a good idea to know how to do this one. Okay, so what I do with this is sketch a picture of it first, and what I would do is just center it at the origin. Okay, so I'm going to try to draw an XY axis, and the dish is 8 feet across and its opening is 3 feet deep at its center. Okay, what does that mean? So if I draw my parabola, that looks something like this. It's a really bad parabola, and I go straight across, no arrows, blue, dotted, why not? Okay, so here's my satellite dish. There we go, my really bad satellite dish, and this is 8 feet across from here to here. Okay? And also, at its satellite dish shape of a parabola, if the dish is 8 feet across at its opening and 3 feet deep at its center, meaning this is 3 feet, you need to, at what position should the receiver be placed? So in other words, what they're looking for is they're looking for the focus. This is not the focus right here. The focus might be somewhere over here, might be somewhere over here, and that's what we're looking for. Okay? So we know that this is a right side up parabola centered at the origin, so it's going to look something like x squared equals 4py. And since it's 3 feet across, I know that this would be the point, since it's 8 feet across, I know that this would be the point 4, 3 over there. Okay? And so what I do is I plug in this point. I can't really plug in this point in the middle because that would make things disappear and you wouldn't get anything. So you have to pick a point out here that's actually on the parabola. And anyway, this point wouldn't be on the parabola. And I plug in the vertex. That's going to give me 0 equals 0, so it's not going to help me. So plug in this point 4, 3. So I'm going to plug in 4 for x, which gives me 16. So this is 16 over here, okay, equals 4p, and y in this case is 3, so you get 16 equals 12p, and you get p equals 16 over 12, which is 4 over 3, which means that this point right here, which is the focus of your parabola, so rays are going to come in here, sound waves or radio waves, whatever they are, they're going to come in here and bounce to this focus, which is 4/3 away from the vertex. So that point right there is going to be 0, 4/3, like that. Pretty easy, right? Okay, last one. So in the last problem, finding the focus, vertex, directrix, and graph. So this is a very similar thing, except this is going to be a y-squared parabola, which we're completing the square. If you think you could do that on your own, you could turn me off right now, or you can continue to follow along. Alright, so I'm going to grab this, I'm going to come up here, and I am going to complete the square. This time let's bring everything first over to the right side, okay, except for the y. So I'm going to go y squared minus 2y equals negative 8x plus 9, okay, and then I'm going to complete the square of this, and you ask yourself, what is 1/2 of negative 2? 1/2 of negative 2 is 1. So I go like that, square that, and when I FOIL this out, I get y squared minus 2y plus 1. So I've added 1 to this side of the equation, so on this other side of the equation, I have to add 1 as well. And now I have 1y minus 1 quantity squared equals negative 8x plus 10, and then what do I need to do? I need to get a number in front of, did I do something wrong? Aha! I'm glad I did something wrong. See? What did I do wrong? You said, Mr. Leader, you're doing this wrong. I need to make this a negative sign, right? Because I subtracted 9 from both sides. So let's back up a little bit here. Okay, so 8x minus 8x minus 9 minus 9 plus 1, right, because I added 1 to both sides, minus 9 plus 1 makes negative 8. So that works out a lot better, because now I can factor out a negative 8 from both of these, x minus plus 1, right? When I factor negative 8, that's what I get. So this tells me that my vertex is going to be at negative 1, comma, positive 1, because it's x minus h, y minus k, right? So this is plus, that makes that negative, and this is negative. So there's the vertex, and I know real quick, so vertex is at negative 1, 1. Call that point right there. And since the number in front of the x is negative, I know that this is, I know that it's a sideways parabola because the y is squared. And B, I know that since this is negative, it's opening this direction. Okay, so something that kind of goes like this. So I'm looking for a focus over here. And since I know that 4p equals negative 8, that means that p equals negative 2, and p is the distance to the focus from negative 1, 1. So the focus is over here at negative 3, comma 1, and the directrix is 2 units away from there, which puts you over here at, guess, x equals, since this is negative 1, 1, I need to go 2 units from negative 1, so this is going to be x equals 1. So now I have the focus, the vertex, the directrix, and I sketched the graph more or less. I should probably plug in a couple points to see what those y values, again, since this number is pretty big, this is going to be kind of a wide parabola. Okay? If this number is 4, then since that represents 4p, then it's a regular old y equals x squared parabola, but this is wider than that. And that's it. So, for homework, there it is, right down there. You can try to do those and come to class with your questions. Thank you. The end.